Hello friends, I welcome you in lecture number 35 on Laplace transform. In previous lecture we have discussed how to find out inverse Laplace transform if we have division by some positive natural power of s. So we just recall that formula. Suppose we have this type of function L inverse of capital F of s divided by s. Then we can use this formula. Inverse Laplace transform of f of s divided by s is given by integral from 0 to t integral of inverse Laplace transform of this function f of s, which is in the numerator, and we integrate this with respect to u from u equal to 0 to t. So this method is helpful whenever we have division by s, therefore we remember this as division by s. So we are going to discuss this question using this method, division by s. So we can see here we have division by s, so we can directly start with this L inverse of 1 divided by s times cube of s plus a. This I can rewrite as, I write s in the denominator, here I write 1 divided by cube of s plus a. So I have L inverse of capital F of s divided by s. I have this type of term here, so I can use that formula. Inverse Laplace transform of f of s by s equal to integral of inverse Laplace transform of f of s. Here f of s is 1 divided by cube of s plus a, and we integrate with respect to u. Now you must be familiar with the formula of this 1 over s plus a cube. So if you recall, because we have s plus a, we will write e raised to minus at, and inverse Laplace transform of 1 by s raised to n is t raised to n minus 1 divided by n minus 1 factorial. So here we will have t raised to n is 3 here, so t square divided by 2 integral with respect to u. Now because we are using dummy variable u here, we will replace this t by u. So now I am writing here, instead of t I am writing u, and instead of t square I will write u square here. So now this is problem of integral. We can take this 1 by 2 outside integral, and we rewrite this as integral from 0 to t u square e raised to minus au du. And now we apply integration by parts. We consider first function as u square and second function as v. First function as u square, second function as e raised to minus au. If you recall the formula of integration by parts, then if suppose I have two functions u and v in the product, then I will consider that function as u whose derivative is 0 after some finite number of steps. This is equal to u as it is integral of v, which we denote by v1, minus derivative of u, that is u dash, integral of v1, which we denote by v2, then derivative of u dash, that is u double dash, integral of v2, which is v3. And here we consider u as that function whose derivative is 0 after some finite number of steps, so that we have finite sum as the answer. So here for u we will consider u square, and v is e raised to minus au. So we understand in this way. So first we keep u square as it is, and we write integral of e raised to minus au with respect to u, and it is e raised to minus a into u divided by coefficient of u, which is minus a. So let me write this in the bracket. minus derivative of u square, which is 2 into u, and integral of this bracket. So it is again integral of e raised to minus au is e raised to minus au divided by minus a, and there is already 1 minus a here, so we will have minus a into minus a, that is going to be a square, plus derivative of 2 into u, which is 2, and again integral of e raised to minus au divided by a square. So we have e raised to minus au divided by minus a, and a square is already there, so we will have negative of a cube here, and limits of integral are from u equal to 0 to u equal to t. Now we substitute upper limit first, we replace u by t. So this is now 1 by 2 as it is. First we put upper limit, so we consider u equal to t. So we will have t square e raised to minus at divided by minus a. So that I write in this way, t square e raised to minus at. Here I have replaced u by t. T square e raised to minus at divided by minus a. Similarly, this is 2t e raised to minus at divided by a square. Negative sign is there. 2t e raised to minus at divided by a square. Okay, fine. 2t e raised to minus at divided by a square. Here there is negative sign, and we have minus 2 by a cube e raised to minus at. Minus 2 e raised to minus at divided by a cube. This is for u equal to 0, that is upper limit. Now we consider for lower limit. So this is for upper limit minus for lower limit. Lower limit is u equal to 0. So because u square is in the product, this term will be 0. Similarly, this term will also be 0. And here we have e raised to 0, that is 1, and we are left with minus 2 by a cube. So that I write here minus 2 divided by a cube, bracket complete. And this again we can rewrite. If we wish, we can take a cube common, e raised to minus at is also common, so we can take LCM, or we can keep it as it is, and we can write this as, first we write this part, it is going to be positive, 2 divided by a cube, and we take negative sign common from each of this, and we take e raised to minus at also common, and if we wish we can take a common also, but suppose we consider e raised to minus at common first, then we are left with t square by a plus 2t divided by a square plus 2 divided by a cube into e raised to minus at. So I am rewriting this. This is positive. I am taking e raised to minus at common. So I am left with t square by a plus 2t by a square plus 2 by a cube e raised to minus at. And if we wish, we can take LCM here, or we can keep this as it is, that is also correct. Suppose I take LCM here, LCM is a raised to 3, then here I have to write t square a square plus 2at plus 2 into e raised to minus at. So either you are writing this or this, both will be considered as correct answer for inverse Laplace transform. So this is nice application of division by S formula. Suppose you are not going in this way, then to find out inverse Laplace transform of this, you have to use method of partial fractions, and you have to find out 4 constants a, b, c and d, because we have s plus a raised to 3. So I have to go up to d divided by s plus a raised to 3, and I have to decide 4 constants a, b, c and d. So this is another way. We can always do in this way also. and because we are having s in the division, we can apply the method of division by s also. So for that we have to remember this formula, which is reverse of formula for Laplace transform of integral of a function. So this is all about this session. I hope you like it.